This lesson is from Chapter 5, Lesson 1, Ratios and Rates. Your essential question, how do rates help you to describe real-life problems? So the meaning of the word rate. When you rent snorkel gear at the beach, you should pay attention to the rental rate. The rental rate is in dollars per hour. So you have two examples there, snorkel rates for $8.75 per hour or snorkel rates for $7.25 per hour. So you can look at those pictures and figure out which one would be the cheaper price, which would be the place that you should go to rent your snorkels. We're going to go over some key vocabulary. Ratio, rate, and unit rate. The first one, a ratio, is a comparison of two quantities using division. First one is written as a fraction. Remember, your fraction bar is always just a simple division sign. You could also write a ratio using the word 2, 3 to 4. And you can use it using a colon, which was also read 3 to 4. No matter which way of the three ways that you write a ratio, they're all read as 3 to 4. So use the word 2 to read a ratio. A rate is an example of a ratio in which the two quantities have different units. So if you look back at your ratios here, there's no units. However, when you look at your rates, you have miles here and hours here. So that's the difference between a ratio having no units and a rate actually has units that you are comparing. So that one we would say 60 miles to 2 hours. A type of rate in which you have a denominator of 1 is called a unit rate. So if I were to convert 60 miles to 2 hours into just 1 hour being at the bottom as your denominator, we would call that, instead of a rate, it is a unit rate. 30 miles per hour or 30 miles to 1 hour. And the last vocabulary term is complex fraction. A complex fraction has at least one fraction in the numerator, denominator, or both. Therefore, you may need to simplify complex fractions when finding ratios and rates. So you might see something that looks like this. This could be an example of a complex fraction. 1/2 to 4. Notice that there is a fraction as your numerator. Or you could have something that says 5 to 3/4, where you can see a fraction as your denominator, also a complex fraction. Or you might have a numerator and a denominator as fractions, 1/6 to 7/8. You have a fraction on the top and bottom of the ratio, and therefore it is a complex fraction. So the first example we're going to look at is finding ratios and rates. It says there are 45 males and 60 females in a subway car. The subway car travels 2 5/10 miles in 5 minutes. Find a ratio. Find the ratio of males to females. So when you're writing it as a ratio, you're going to use exactly the way they want you to. Males to females. So males should come first to females if you're writing it as a fraction. If I look back at the top, I can see that there are 45 males and 60 females, so I would write it as 45 to 60. That's one way of writing a ratio. Remember, you could also write it using your colon or with the word 2, 45 to 60. And for all of them, we're going to actually simplify it because it's not in simplest form. If I look at 45 and 60, they are both divisible by 15. Therefore, we would divide by 15 to simplify that fraction. 45 divided by 15 is 3, and 60 divided by 15 is 4. So the ratio of males to females would be 3 to 4. We don't want to read it as 3/4 because it's not just a fraction, it's a ratio comparing males to females. So we want to say 3 males to 4 females, or just simply 3 to 4. Then we're going to find a rate, and remember, a rate is now going to involve units. So find the speed of the subway car. So if I'm looking at the subway car, I can see that it travels 2 5/10 miles in 5 minutes. 2 5/10 miles in 5 minutes. And a rate, again, can be written as a fraction, so we would write it as 2 5/10 miles to 5 minutes. And that can also be simplified if we want. Both 2 5/10 and 5 are divisible by 5. And if we divide by 5, we end up with 5/100 miles to 1 minute. And notice, since I have a 1 down here, this would actually be considered a unit rate, because we just converted that rate to now have a denominator of 1, and anytime you have a rate with a denominator of 1, it is known as a unit rate. The on your own problems. In example 1, find the ratio of females to males. And in example 1, find the ratio of females to total passengers. So using the information from example 1, see if you can answer those 2 on your own problems. Pause the video and come back and check your answer. For example 1, males to females, I'm going to write down here, number 1. We're now going for females to males. Sorry, we already did males to females. Now you should be thinking for females to males. Your females should be on top and your males should be on the bottom. It said that there were 45 females and 60 males. And you're always going to simplify your answers. Both of these numbers are still divisible by 15. 45 divided by 15 would give you 3 females, and 60 divided by 15 would give you 4 males. So we've got 3 to 4 for that one. Did I do that wrong up here? 45. I'm sorry, females to males should be 60 over 45. I just flip-flopped it. I knew that it was wrong because I gave me the same answer that I had up top, so that would be your clue. If we already did males to females and it was 3 to 4, it wouldn't make sense that females to males would also be 3 to 4. So our females are actually 60 females over males, which is 45, and then we can do our division by 15. 60 divided by 15 is 4. And 45 divided by 15 is 3, so that makes more sense. It's 4 females to 3 males. Notice that it is the opposite of what we got up top here. In number 2, they're asking you to find the ratio of females to total passengers. So in number 2, we know that females goes on top, and our total goes on the bottom. So there are 60 females still. And then your total would be your females plus your males, which gives me 60 to 105. And we're going to look to simplify that guy. Both of these are also divisible by 15. 60 divided by 15 would give me 4, and 105 divided by 15 would give me 7. So the ratio of females to total passengers would be 4 females to 7 total passengers. And those problems were on the second page of your packet if you didn't see them. We're now going to go to the next example. Example 2, finding a rate from a ratio table. As the ratio table shows the costs for different amounts of artificial turf. Find the unit rate in dollars per square foot. So we know that we want to do cost, or dollars, per square foot And if we take any of those examples from your chart, we know that we have $100 for 25 square feet. That would be here. Or you could pay $400 for 100 square feet, or $1,600 for 400 square feet, or $6,400 for 1,600 square feet. So if we want to find the unit rate, remember we want to have a 1 as our denominator. We can start off with any of the different examples from the table. If I do my cost of $100 for 25 square feet, and I want to know the unit rate, I want this bottom number, this square footage, to be a 1. This is $100 for 25 square feet. I want to know, what does it cost for 1 square foot? Anytime you're going from a rate to a unit rate, simply dividing would take you to that 1, or you could look at it as a proportion. If I'm solving my proportion, I've got 25x equals 100. Then to get x alone, I need to divide both sides by 25, which takes me back to 100 divided by 25, which is simply here. So you can just do the division to take you right to your unit rate. This gives me x equal to 4. X is up top, which is money, which means we have $4 per square foot. We want to write it as a ratio, $4 over 1 square foot. This is just me squaring the foot, so this should actually say foot. $4 per feet squared, or square foot. And that would work for any of them. If I took the next one, if I did $400 for 100 square feet, and I were to divide those, 400 divided by 100, still gives me that $4 per square foot, or feet squared. Alright, still giving me $4 over 1 square foot, depending on how you want to write it. Right? Unit rate always has that 1 on the bottom, which is what this is. Per square foot means per 1 square foot. That's what a unit rate is. So looking at that table, see if you can answer number 3s on your own problem. Actually, it gives you a new table to look at. In this one, the ratio table shows the distance that the International Space Station travels while orbiting Earth. Find the speed in miles per second. So you're looking for miles over 1 second, per second. See if you can take one of the ratios from the table, or rates from the table, and change them into a unit rate. Pause the video and then come back and check your answer. So since we're doing speed in miles per second, we're thinking of miles over 1 second. So you can pick any of your miles from your table. I'll go with the first one, 14 4/10 miles in 3 seconds. If you want to set it up as a proportion, that's fine. 3 times x is 3x. 4 4/10 times 1 is 4 4/10. Solving for x by dividing both sides by 3 will leave you with x equal to 3x equal to 14.4. I missed this 4 here. And 14 4/10 divided by 3 leaves you with 4 8/10. And again, that would be miles per 1 second. All right, notice that this 1 is here, making that your unit rate. And if you were to pick any other one, if I did 28 8/10, and instead of doing a proportion, I'm just simply going to divide the numbers. 28 8/10 divided by 6 still ends up giving me 4 8/10, and that would still be miles per second, just another way of writing per second instead of having it over 1. Right, so the most important thing here is having that 1 on the bottom of your rate, which makes that rate a unit rate. If we move on to example 3, finding a rate from a graph. It says step 1, choose and interpret a point on the line. We're going to actually look at both points on the line and interpret what they mean. Our first point here has the ordered pair 1/2, 1/4. Remember, in an ordered pair, x comes first, followed by y. Notice that this is your x value, and this is your y. These are your axis. X-axis is your horizontal axis, and your y-axis is your vertical axis. So when you're graphing a point, you start at the origin, which is here. You go either left or right first on your x-axis, and then up or down on your y-axis. So in order to interpret what that means, we want to look at what the actual x-axis is representing, which we can see here. So that's time in minutes. So that means that 1/2 would be your time in minutes. And on your y-axis, you have your distance in miles, so 1/4 is representing your distance in miles. So when I go to interpret that, I would say that I am traveling 1/4 miles in 1/2 of a minute. So yes, when I'm writing my ordered pair, x comes first. When I'm interpreting it, it makes more sense to say that you went 1/4 mile in 1/2 a minute, or rather than 1/2 a minute for 1/4 mile, right? Because speed would be distance over time. The other one, 3, 1 and 1/2, would mean that you are traveling 1.5 miles in 3 minutes. Right? We're just interpreting what those ordered pairs actually are representing. Then they're asking you in step 2 to find the speed. So you can see speed is given as distance traveled over your elapsed time. Your distance traveled is going to be in miles, and your time would be in minutes. So we're looking for mile over minute. So we already know from our first ordered pair, our mile is 1/4, and our minutes is 1/2. Oops. So we got 1/4 mile, or 1/4 mile, in 1 to 1/2 minute. So what's happening there is we've got an example of a complex fraction. Remember, that was your vocab from the very beginning. When you have a fraction within the fraction, whether it be as just your numerator, as your denominator, or as both. So here we're looking at it as both. We have a fraction as your numerator as well as your denominator. So in order to simplify that, you're thinking of this as a division problem. So I could rewrite this as 1/4 divided by 1/2. The rule for dividing fractions is always keep, change, flip. We find the reciprocal of 1/2. Keep is your 1/4. You change from division to multiplication. And the reciprocal of 1/2 would be to flip that, which would be 2/1. We're going to cross cancel because I can see that 2 and 4 are both divisible by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. And then we can multiply across. 1 times 1 is 1, and 2 times 1 is 2. So we end up with 1/2. We're going to go back and write in our speed, 1/2 miles per minute. And since it's per 1 minute, again, that would be a unit rate. That's how fast they're traveling per minute. If you did the other ordered pair, you should end up with the same answer. So let's look at that one as well. We've got 3 and 1 and 1/2, which means we've got 1 and 1/2 miles in 3 minutes. Therefore, what's their speed? What are they traveling per minute? So I would do 1 and 1/2 divided by 3, changing from a mixed number to an improper fraction. 2 times 1 is 2, plus 1 is 3. So we're looking at 3/2 divided by 3. We're then going to do keep, change, flip. 3/2 times the reciprocal of 3/1 would be 1/3. Cancel these guys out because they're both divisible by 3. Multiply across. 1 times 1 is 1, and 2 times 1 is 2. Notice we end up with that 1/2 again, and it would still be miles per minute. So it doesn't matter which ordered pair you choose from the line that is showing that subway car speed, both of them are going to give you that same speed. They're traveling at a constant rate. That rate that they're traveling is 1/2 miles per minute. Example 4 is a lot more complicated. We're going to look at solving a ratio problem. So we're going to break this up into different colors of paint. It says you mix 1/2 cup of yellow paint for every 3/4 cup of blue paint to make 15 cups of green paint. How much yellow paint and blue paint do you use? So for the yellow, we've got 1/2 cup. So I've got yellow to green, and green we know is 3/4 of a cup. But this green down here is coming from both yellow and blue together to get to green, because yellow and blue make green. So the bottom of my fraction needs to be my yellow still, my 1/2, plus my blue. Yellow plus blue is green. So we would have to add those two together. We'd still have 1/2 up top. If I add 1/2 to 3/4, I'm going to write it as an improper fraction. That gives me 5/4. Remember, when you are adding fractions, you'd need a common denominator. So I would have to change that 2 to a 4, doing that by multiplying by 2. So I actually have 2 up top, because 1 times 2 is 2. And 2 plus 3 is where I got that 5 from. So again, I'm looking at a complex fraction. We know that this is simply a division bar. I'm going to come down the bottom and do the division. Got 1/2 divided by 5/4, which becomes 1/2 times 4/5. Quick change, flip. I got some canceling that we can do. 2 and 4 are both divisible by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Multiply across. 1 times 2 gives me 2, and 1 times 5 is 5. Right? It says we're making 15 cups of green paint. So how many cups of yellow will I need for those 15 cups? I got to figure out, since yellow is 2/5, what is 2/5 of 15? We know that of in math means to multiply, so we're going to do 2/5 times 15. Put that over 1. Canceling the 5 and the 15, they're both divisible by 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. And then we can multiply across. 2 times 3 is 6. 1 times 1 is 1, which means we're going to need 6 cups of yellow. Then we're going to do the same thing to figure out how many cups of blue we're going to need out of the 15 cups of green paint. So I know that blue has 3/4 cups, and green is still my yellow plus my blue. So we're left with 3/4 to 5/4. Again, a complex fraction. I'm going to come down here and do my division. 3/4 divided by 5/4 becomes 3/4 times 4/5. Canceling the 4's that are both divisible by themselves, they become 1's. 3 times 1 is 3, and 1 times 5 is 5. So we have to figure out now what 3/5 of 15 is, because we're asking for how much paint do we need to use in those 15 cups of green. So we're going to multiply 3/5 times 15/1. Canceling the 5 and the 15 are both divisible by 5. Multiplying across, 3 times 3 is 9, 1 times 1 is 1, which means we will need 9 cups of blue to make those 15 cups of green paint. So we had to figure out how many cups of yellow there would be to create green, and multiply it by 15 because we wanted 15 cups of green. Then we figured out how much blue we would need out of a green cup. and multiply that by 15 to come up with how much we would need for 15 cups of green. On your own problem, they're asking how much yellow paint and blue paint do you use to make 20 cups of green paint? Well, we already know that yellow, for each cup, yellow is 2/5 cups. This is your yellow. And we already know that blue is 3/5 cups. Figure out how much you would need for 20. So up here we figured out how much we would need out of 15 cups. You're going to find out on your own how much you need out of 20. See if you can solve those two on your own, and then come back and check. Pause the video. So for yellow, all you're doing is figuring out what 2/5 cups of 20 is. 2/5 of 20 would be 2/5 times 20. Put it over 1. Looking to cross cancel, 5 and 20 are both divisible by 5. And then multiplying across. 2 times 4 is 8. 1 times 1 is 1. So for 20 cups of green, you would need 8 cups of yellow. Same thing for blue. You're going to do 3/5 cups of 20. We got 3/5 times 20. Canceling across, the 5 and the 20 are both divisible by 5. 3 times 4 is 12 over 1, so we would need 12 cups of blue to make those 20 cups of green paint. That's the end of lesson 5.1.